So here's something crazy. There's this place in Canada here in Nova Scotia, Canada called the Bay of Fundy. And in particular, at this one place in the Bay of Fundy, right over here, there is this has the highest tides in the entire world. And it's extreme. It's insane. And I'm going to show you a video now about the tides here. So there's obviously a sped up video, but you'll see it here. So you can see the time and the height of the tide as it comes in and out. And think about how big a tree is, and think about what kind of scale we're talking here. Obviously, it shows the height. It goes up to 50 feet there. And this is incredible. And you can actually go and get data about the tides in this location on Canada's websites for fisheries and oceans. And so if you click on the region of Canada that this is in, and then Bay of Fundy's in, looking at this region here, and then if we want to get Burnt Coat Head, which is where this place is, you can actually pull up tide data for each day. These are predictions because today, as I'm recording this video, is May 6th. But you can go and you can also get these predicted hourly heights. So not just when the high and the low tides are, but then also exactly what hour and what height the tides are. And I took this data, these hour values and these height values for today, and I put them into Desmos. And so when I put them into Desmos, this is what they look like. Obviously, we've been talking about trigonometry. This looks sinusoidal, and this should make sense to you because one of the main things that controls the tides on Earth, well, the main thing is the moon. And so the moon kind of circles the Earth in a fairly regular, interval, like kind of goes up like every 12 hours. The moon is up, or down, or whatever. So we've got like this data is sinusoidal, and wouldn't it be so cool if I could figure out like what would the tide be just based on this data for this one day? What if I wanted to know the tide 3 days from now? Well, you could do a reasonably accurate job of predicting this, and the way you do it, and there's a very commonly used tool in science and modeling for predicting natural phenomena like weather and stuff, is through a regression. And so we're going to do a sinusoidal regression. This here should look pretty familiar to you. A is the amplitude, omega is it is the modifier of the period, P is a phase shift, and B is a vertical shift of this data. And so this symbol here is how we do a regression. We're going to do a regression from the X values input in terms of the Y values that came out of the inputted X values. And so we get this graph. And so if we wanted to know like way down in the future, what would the tide be, hour 60? Well, it looks like the tide would be about 9 meters. By the way, the high tide here of 14.9 meters, that's 49.17 feet. That's very high. It's frighteningly high. Imagine if boats were riding that out, like if you had a boat docked. There are plenty of docks on the Bay of Fundy. Halls Harbor, if you YouTube a video called Halls Harbor Bay of Fundy Tides, you'll see a pretty crazy video. But what's cool, so if you have this regression and you write it in a function form, you could then just say, all right, what's the tide going to be at any time? And it'll spit out a value for you. And so we're going to be talking about sinusoidal regression, and this is totally possible to do this by hand pretty accurately. But when we do the example by hand, it's going to be with like kind of nicer numbers, a little bit, like not as decimally